Good morning, good evening, good afternoon, everybody. My topic on biosecurity to respond the risk of emerging diseases in shrimp aquaculture. My name is Jie Huang from the network of aquaculture centers in Asia Pacific. The farmed production of paneled shrimps in non-member countries, you can see here in the figure, most country group in four. You can see China has the highest production. Based on this production, it's log based production. So, and Vietnam, Indonesia, India, Thailand is group 2, and Philippines, Malaysia, Myanmar, Malaysia, and Iran is group 3, and Sri Lanka and Australia is the group 4. And due to the disease problem, you can see the fluctuation of the production in each year. Some countries lose the production in some years. And currently, the shrimp aquaculture face lots of disease problem. Normally, we see shrimp cultured in the farm environment, and if you have a bad management, then the disease, the opportunistic Vibrio species will cause disease. And nitrogen will also cause disease, white spot, CMNV, and VP, and EHP, and DIV1. So it causes the white spot, reddish body, COVID mortality, EMS, append, white feces, and the slow growth. So many diseases. I will talk later for the emerging one. And the problems related to the aquatic animal health is not only on the loss of production. This loss of production also not only due to this mortality, but also it will cause slow growth due to infection and raising cost of prevention and control. It also really will link to the public health risks, such as antibiotic resistance due to the use of antibiotics and zoonosis. Also, product safety risks will bring, like drug residues. And the trade risks include cross-border transmission, production qualities, decline, safe sanitary barriers, and also wild ecological risks, such as infection in the wild populations and pathogenic mutations. Also environmental risks, such as environmental drug residues. Also social risks, including crisis of trust in governance, social economic impact, social stability, and also finally the sustainability risks, including increased spending on prevention, productivity decline, negative in industry public opinion, and falling investment. So many disease, especially for the emerging disease, is concerned by the industry. The first one, recent concerned disease is Decapolivirus virus called DIV1. This is the disease agent. It's a new species in genus Decapolivirus of family Iridoviridae. This to isolate when it was found, called CQIV and SHIV. It can infect almost all tested penned shrimp, including Pallas valami, Pallas monodon, and also Microbranchim, Rosenbergi, and also crayfish. This virus was firstly found in China from Cherex Carilatus and Pallas valami, sampled in 2014. And wild tiger shrimp Pallas monodon caught in Indian Ocean was detected positive. DIV1 was also reported in Pallas valami, Pallas Pancreatic Clarke in Taiwan province of China in 2019. The disease will cause almost 100% mortality to Pallas valami and Microbranchim rosenbergi in 2 weeks. This, based on this surveillance in China, this disease has the relationship between DIV1 detection and the water condition shows the positive rates peaked at 26 to 28 degrees centigrade and decrease significantly at the temperature above 22 degrees centigrade, and the mortality positive appear at the pH 7.5 to 8.4, and more positive appear in the fresh water. Another is covert mortality Lobster, CMV. This affected species has reported many different species, including penned shrimps, and also Pancreatic, and also other species, even for fish. The disease risk seems the shrimp infected with CMV may or may not show clinical sign. Mortality was reported up to 8%, but also there's some report mentioned there's low clinical sign in some case. Also, this disease present in China, first reported in China in 2014, and it was reported in Thailand without clinical sign. Another is Ocavirus 1. Actually, this virus originally called yellowhead virus type 8, but right now ICTV classified this virus as a new species, so it gave a name called Ocavirus 1. This virus was firstly found in China in 2012 and reported in 2014. Infected species included Panis chinesis, Panis valami, Panis japonicus, and Panis monodon. Disease risk included clinical signs were reported in Panis chinesis with mortality 50 to 80%. Another new species disease virus is called Microbranchim rosenbergi Ocavirus, MRGV. This disease was firstly found from Bangladesh hatcheries of Microbranchim rosenbergi in 2018. Also, this isolate was recently identified in farmed Microbranchim in China without a clinical sign. The affected species is Microbranchim rosenbergi, and the disease found in Bangladesh is associated with a mass mortality up to 100% of larvae prawns. But in China, the isolated identified virus has not found associated with a clinical sign. Another one is Microbranchim virus, MRTV. This virus is related to the Aquavirus, family Decapolivirus. Also, the affected species Microbranchim rosenbergi. It was firstly found in China in 2016. The disease risks is infection with this virus cause larvae mortality syndrome, and mortality reached to 53 to 82 within 20 days. Another one is called Crosscross Hypervirus, Hyper-like virus 1, CHEV1. This virus was identified based to the sequence. The affected species is Microbranchim rosenbergi also, but there is low reported disease. So the disease risk is unknown. There are also lots of RNA viruses identified in crustaceans with RNA-dependent RNA polymerase sequence, including Wenzel shrimp virus 1, Wenzel shrimp virus 2, Wenzel crab virus 1, Wenzel crab virus 2, Wenzel crab virus 3. So this virus was classified to different group of virus, and also all of this virus has unknown clinical affection. So if it's we don't know if this virus will cause disease. In 2016, there is more virus reported. Newly found from crustacean virus, there is 394 RNA viruses was reported from crustaceans. You can see in different group, there is many RNA virus. new RNA virus found. So it seems that there's so many viruses in crustaceans, potential to cause risks. But also there's low reported disease linked to associated with these founded viruses. And another is virus related similar to Wenzel-virus, shrimp virus 8. This is a newly identified virus similar to the reported shrimp virus WZSV 8, isolated from glass post-larva. It's like the same virus, so-called Hyperpancreatic and intestinal necrosis virus, HINV, was reported. And the affected species, Panis valami, and this is identified in China in 2020. The disease risk, it seems this may cause the growth associated with the glass post-larvae, but this pathogenicity is still ongoing for repeating pathogenic testing to post-larvae from PR1 to PR10. And low significant pathogenicity in larger PRs. Other new emerging disease in recent decade is acute hepatopancreatic necrosis happened. You may mostly know this disease. This disease is caused by Vibrio species carry plasmid PAB-VP gene, including Vibrio parahemolyticus, Vibrio ovens, Vibrio campbelli, and Vibrio panicis. It has been demonstrated that plasmid can transfer between different Vibrio species, and this disease affect the Panis valami and also Panis monodon. But there's also some other event, but without incomplete evidence for Panis genesis and Panis japonicus. This disease was firstly reported in China and Vietnam in 2010, and then to Malaysia and Thailand and the Philippines, and also recently extended to other continental. The disease caused rapid death in juveniles with mortality higher than 80%, and mortality depends on the virulence of different strains of bacteria and the age of shrimp. There's other diseases. I use the name digestive, pathogenic, Dysbacteriosis. This disease agent is Dysbacteriosis of Hyperpancreatic and intestinal microbiota dominated with pathogenic Vibrio species, including Vibrio parahemolyticus, Vibrio cellulosis, Weber Hawaii, Weber neo canidonicus, or Weber angulonicus syndrome, with LD50 around 10 to 5 to 10 to 6 CFU per gram body weight. The most affected species is Penis volami. This syndrome has no silo limbs. For grew out period, it can include the white faces syndrome, hepatopancreatic necrosis syndrome, septic hepatopancreatic necrosis, running mortality syndrome. For post-larvae or juveniles period, it can include glass post-larvae, translucent post-larvae disease, bacterial vitrified syndrome, early mortality syndrome, EMS. And this syndromes also was reported in China, India, Indonesia, Malaysia, and Thailand. Another bacteria is Spheroplasma, found in Microbranchim rosenbergi. This pathogen, isolated from Microbranchim rosenbergi, was Spheroplasma and had a close relationship with all other Spheroplasma strains from freshwater crustaceans. And it was reported in China. And after challenge for 23 days, the challenged group had a 20% survival, while the negative control and the blank group were 86.7% survival. Also, the Enterocytose hepatopenia, EHP, also is an emerging disease in many countries in this decade. This actually is belong to a kingdom of fungi, but mostly people think it's a parasite. Actually, it should be a fungi. Affected species include Penis molodon, Penis volami, Penis japonicus, and but Penis japonicus was unidentified. The PCR positive was detected in the Procampirus clarki and Microbranchim rosenbergi, Penis chilensis, Microbranchim nipponiensis in sample of nature targeted surveillance. And this disease was firstly found in Thailand, and then found reported in Vietnam in 2010, in China reported in 2016, India, Indonesia, and Malaysia. I only talk about Asia countries, not included other continental countries. So maybe they are also reported in some other country. And on this unclassified microsporidium species were reported in Hyperpancreas of Penis shrimp in Malaysia and Australia. This fungi cause in population level, the growth and EHP load in Hyperpancreas showed negative correlation when EHP load in the lower. If the EHP load is higher than 10 to 3 copies per negative nanogram Hyperpancreas DNA, it will show growth inhibition. The relationship between EHP and white faces remained controversial. Another is a Milky blood disease found in crabs, including Porteus trituberculosis and also Porteus pelagicus and Scylla serrata and other species. This disease is caused by hematodidium. This is also a microbranchim. It's not a microsporidium. It's another one. I'm sorry. The disease risk if injection with inoculum can reach accumulative mortality of 60%. It has been this disease has been reported in China, also Australia in 1994, but 2013 is emerging on new species. And also toothpaste crab disease. This disease agent is Amazon portunus under the order Crustacea class Marilosporidia. It's also a microsporidia. I'm sorry, the earlier one, previous one, also a microsporidia. Affected species is swimming crab. Disease risk is incidence of farmed crab can reach 70%. And whitened musculature of spinning lobster. This is caused by Amazon ECB species. This is a new species founded. Also, is a microsporidium. This pathogen was identified in Japanese spin lobster and reported in Japan. The mortality has not been confirmed yet. Affected lobster lose marketability due to the poor aesthetic appearance. With this concept, to prevent the disease, that means we need to prevent the infection, prevent the pathogenic agent. So that's the concept of biosecurity. The biosecurity definition is referred to the cost-effective management of risk posed by infectious agent to aquaculture through a strategic approach at enterprise, national and international levels with shared public-private responsibility. This is based on FAO definition established recently in 2019. To understand this meaning, actually the biosecurity is three major parts. The one is the target of the concept is aquaculture system. And the objective of the biosecurity is to reduce the risks of introduction, spread, and release of infectious agent. The means is a set of cost-effective management and physical management at aquaculture system. This concept is risk analysis based. In order to include all possible farms and hatcheries to use the biosecurity plan, we propose this 5-level biosecurity grid. The first level is aquaculture biosecurity grid 1. Is we call is disease diagnosis-based treatment. Is controlled according to diagnosis or contingency plan only, without surveillance and risk assessment. It can use for traditional extensive farms. And Biosecurity Grid 2 is surveillance-based prevention. It can use for intensive or indoor farms. And Grid 3 is we call risk analysis-based control. Can use for larvae rearing hatcheries and nursery hatcheries. And Grid 4 is systemic disease-free, can use for breeding centers and broad stock producers. And Grid 5 is official certification for disease-free license hatcheries or farms. So this is the difference in technological use application for farm biosecurity plan. You can see the higher biosecurity grids, then you need to use more measures in the biosecurity plan. This is my talk. Thank you for your attention.